All right. Good afternoon. Colored pens up. So let's see how we're doing with solving equations by graphing. What did you get as your solution or solutions? Start with Kalasia, Stephanie, Edgar, Davis. No solution. You agree? Okay. You agree as well.
There's absolutely no solution.
Absolutely no solution. 4 people think that it's no solution. It is no solution. I'm going to reveal the graph in a moment, but could someone tell us, in all cases that are no solution, what will we notice about the graph? Without even seeing the graph, what will be true about it? Caleb? That was a beautiful way of saying it. I love the way you said it. And she is absolutely correct. Here is the graph. And you can see the x-axis way down here. And it never touches the x-axis. So there is no solution to this. You could have used quite a few different tables to construct the graph. This was my table. That's the table that I used. And you'll notice that I went 0.5 to the right, and I went 0.5 to the left, and then I went 1, and then I went 1. So since I mirrored the distance, I got a perfect mirror image across the axis of symmetry. Before I could do that, I had to find this. Could someone remind us how we find that? I was pretty impressed that a lot of you knew. Sebastian? Yeah, the opposite of B over 2A. You had to write the equation in standard form first, and so we end up with x squared minus 5x plus 11 equals 0. And then we plug in the opposite of B over 2A. Excuse me. Comments, questions, concerns? So in actuality, even though this was an example from 10.3, this was actually 10.3, 10.2, and 10.1 all wrapped up together. Because 10.1 and 10.2 were teaching you how to graph, and then in 10.3 we learned that we were looking for something when we were graphing. We were looking for when the graph crossed the x-axis. Does anyone have any questions, comments, or concerns about today's warm-up? You will have to be able to do this on your own very well tomorrow when you have your quiz. Does anyone have any questions? Good. Put the warm-up to the side. Today we're going to be solving quadratic equations again. You saw by today's warm-up that we've been solving quadratic equations, but during the warm-up you solved it using a graph. Today you're going to learn how to solve quadratic equations by using a square root technique. Before I get into the lesson here, I'd like to direct your attention to the whiteboard. And you see I have an outline of some things that you've learned already and some things that you're going to be learning. Not only that, I've put it in the sequence that is basically the sequence that you learned it in, but also the sequence that it should go through in your mind. In Chapter 9, you learned all of these methods of factoring. You did not know any of this existed at the time. In Chapter 9, I went through this sequence with you, and I have asked you, even still today, that you should be able to tell me this sequence of things that you're supposed to go through in your mind. First thing you do is factor out a greatest common factor. Then, see if it's a difference of two squares, see if it's a perfect square trinomial, try grouping. If none of those work, then you do the trick. Then, I took a different route. We started Chapter 10 and we started graphing. And that was the key piece. That was the key connection, is understanding that everything you had already learned actually had a picture that went with it. And if you look at the picture, the graph, in the right way, you can find the same pieces of information that you can find by factoring. They're called solutions or roots. Today, you're going to learn the third method that I've listed here, square roots. It's a great technique, but it only works in certain situations. Let's start with some basics about square roots. First of all, what is the symbol, what does it look like, and what does it mean? Well, if you have the symbol by itself, technically it means give me the positive square root. For example, the square root of 9 is 3. Can someone raise their hand and tell me what's the square root of 144? Raise your hand. What's the square root of 144? John? 12. Very good. So you can tell me the positive square root. But in actuality, there are two square roots to every number. There is a negative square root as well. Because what this really means is, what number times itself equals 9? Well, negative 3 times negative 3 equals 9. So there are actually two square roots. Now, we're not going to be worrying about this notation over here that much. We will be dealing with what's over here. When we solve equations, we will be doing this, finding the positive and negative square roots of a number. How many times does the graph of a parabola usually cross the x-axis? How many times does it usually cross? Dalton? Once, usually? Twice, usually? Well, I don't know, you seem indecisive because I kind of kept prodding you a little bit. One time? What do you think, Nathaniel? Twice? Well, we've learned that it can either cross no times, one time, or two times. But a lot of times it crosses twice. And right here is one reason that also illustrates what's going on. Plus or minus 3 is not something new. That just means positive 3 and negative 3. It's a fancy way of writing 3 and negative 3. That's it. So don't think I'm introducing some new magical way of writing numbers. It's not. It's a shortcut way of writing 3 and negative 3. That's it. Here's another important piece that we're going to explore for the rest of the chapter. There is no such thing as the square root of a negative number. You can't. It's impossible. Because if you think about it, what number times itself could be negative 5? Can't be done. There's no number that will work. It doesn't exist. So if you have the negative inside the radical symbol, inside the square root symbol, then we have what's called no real solution. And you've seen no real solution before. No real solution means it doesn't cross the x-axis. So how does all of this fit in? We're talking about particular types of equations that look like this. X squared equals a number. If we have a quadratic that does not have a middle term, meaning there's no x term, then we can write it as x squared equals a number, and we can find square roots. Here are a few examples of what you're going to see today. X squared equals 144. There are two solutions to that equation, 12 and negative 12. X squared equals 0 has only one solution, because when you take the square root of 0, you get 0. You don't get two different numbers. There's no such thing as negative 0. And if you have x squared equals a negative number, there's no solution, because you can't take the square root of a negative number. If you don't know what I'm talking about yet, that's okay. When you start seeing it in practice and you start going through some examples, it'll start to make more sense. Also, for my highly advanced students in the room, pay attention, extra attention today, because you're going to see some examples that you've actually seen before. You're going to see some examples that you actually saw in Chapter 9 when we were learning difference of two squares. In Chapter 9, I taught you to do it a different way. You should be able to do it this way and the way I teach you today. And you should understand why you get the same results. If I have time, I will be demonstrating it as well, but again, my high-level students should be able to make the connection themselves. So, we're going to jump in and start learning how to do this. You do not have to copy the instruction part. You have to read it carefully and understand that I put it there because you're going to see the same instructions in the textbook and in the workbook. I want you to understand what you're being asked. First off, I want to be clear that this technique only works when there's no middle term. Middle term is the x term. There's no x term in part A. What this means is we can now actually solve for x squared and then do something at the end to find our answers. So in other words, what would you do if this was the equation? What would you do first? Only 4 people can tell me what you do first. Fun? Good. Subtract 14 from both sides. This cancels out, and we're left with 7x equals negative 14. What's the next step that you would take? What's the next step? Stephanie? Divide both sides by 7. This cancels out, and you're left with x equals negative 2. That would be the solution if it was a linear equation. But it is not linear because this is actually here. We don't ignore that. So let me put the squared back in. This is really 7x squared, and this is really x squared equals negative 2. Now we have one final step at the end. What we do is we take the square root of both sides. This is how you write it. Square root symbol on the left, square root symbol on the right. The reason we do that is because the square root of x squared is x. When you square something, you're multiplying it by itself. When you square root something, you're asking what number times itself gives me that number. So square root and squared undo each other. They're opposites. Just like subtracting 14 and adding 14 are opposites, Square root and squared are opposites. And so we end up with x on the left equals, and now we have to take the square root of -2, and since that's not a perfect square, we're going to need to use our calculator. Nathaniel? Why is it impossible? That is correct. I was hoping someone was going to say that. Make me stop what I was doing. Yeah, you cannot take the square root of a negative number. It is impossible. There is no solution to this. And so what that means is we write no solution. Excellent job. Does anyone have any questions on how we did that? Just to make sure we're clear, the only thing new that you really learned was this step right here. The rest is material and concepts and skills that you already knew. Any comments, questions? Valerie? Okay, now I have a thought question. We are not going to graph this, but if we did, what would we notice about the graph? 1, 2, 3, 4, 5, 6, 7, 8, 9 light bulbs. Good, Alexandra? Okay, what were you going to say, Davis?
It would never touch the x.
Okay, very good. Yeah, it's never going to touch the x-axis. That's what no solution means. And so what Alexandra and Davis and the 7 other people who had their hands raised, and I think we're going to say the same thing, you're demonstrating a higher level of thought. You are now able to connect what you learned in the past to what you're learning today. Critical ability. So I'm proud of you guys who were making that effort. Does anyone have any comments or questions about part A? Dalton? Go ahead. You have? Okay. Let's find out. So we're going to solve it using the technique today. Instead, in the past, what we did was we got a 0 here by bringing everything to the left. But today, we're going to actually bring everything to the right to isolate the x squared. So what's the first thing we should do? Chris? Very good. So you should be reaching way back to your chapter 3 skills, and this should be effortless for you. I mean, we're talking Jedi Master level for all of you. And we end up with -5x squared equals -30. What should we do at this point? Edgar? Good, and I love the way you said that. Divide everything by -5. This disappears, and we're left with x squared equals 6. Now, we have an x squared. So the solution is not 6. It's saying what number times itself gives me 6. So now the only way to really effectively find a solution is to take the square root of the left, take the square root of the right. We get x equals, now we're going to need our calculator because 6 is not a perfect square, and you already knew that because you've memorized all of them. Here's how you do square root on most calculators. You punch in the number, and then you hit the square root button. Some of you who have scientific calculators might have to type in the square root symbol, then the number. You're going to have to learn right now how to do it. So I'm going to push the square root key, and I get this number, which looks like it's possibly a repeating decimal. But you'll see in the instructions it says, express your answers as integers or as decimals rounded to the nearest hundredth. So what will this round to? Only 4 of my students can round effectively. My quiet students, stay on your toes because I'm going to call on you for questions just to keep you involved. Kadir? Yeah. So we get 2.45. Now, if we circle that, we will get it wrong. Because there are two solutions when you take the square root of a number. And so you have two choices. You can either write it like this, or if you're high level, you can write it simply like this. Bless you. They have the same meaning. This symbol means positive 2.45 and negative 2.45. And so there are two solutions. I am warning you now, you're going to see it a whole bunch of times today, but I am warning you now that if on the quiz in a few days you're asked to do this and you do everything right but you forget to put plus or minus, or if you forget to write both answers, you will get it wrong. Because there's a huge difference. There's a big difference between there being one solution and two solutions. Any comments or questions on part B? Okay. Part C. What's the first thing we should do to solve this? Valerie? Good job. Add 7 to both sides. And you end up with 1/2 x squared equals 8. Oh, I hate this. How do you get rid of that 1/2? Awful. Disgusting. Oh, we got a lot of people want to do it. You got it? You could do that and it would work, but unfortunately that's a confusing way of writing something. Dividing a fraction by another fraction is a very confusing thing to do and to look at. So you were actually taught something different. And so what was the other approach, Exol? Very good. Instead of dividing, you multiply by a reciprocal. Multiply by the reciprocal, that will also get rid of it. And now we're left with x squared equals 16. So the solution is not 16. What we're saying is what number times itself will equal 16? Nathaniel? Yeah. Without even having to draw the symbol, you already knew, since it's a perfect square, that x is going to equal positive 4 or negative 4. And so the two solutions are 4 and negative 4. Does anyone have any comments, questions, or concerns about how we did that? Make sure you're putting positive, negative, or writing down both answers. Okay, again, this could also be written x equals 4 and negative 4. I don't care, either way. Any questions? Okay, so now, because my students are very high level, sometimes my students overthink things. And so I like to show you some low-level questions if I need to, so that you can see that it's not harder, it's really just a very simple form of what we just did. So now we are going to breeze through these. The other ones took 1, 2, or 3 steps. Actually, I'm sorry, took 2 or 3 steps. Now we're going to see 1 step, 2 steps. X squared equals 100. There's nothing to do. What number times itself equals 100? John? X equals 10 or negative 10, and so we need to write that. And if you are being technical, then you will actually draw that out to demonstrate you know what's going on. And John was right. We get positive 10 and negative 10. Any questions about that? What about part B? My super high level students can do it mentally, but we're going to actually do it. Dalton? Good. Divide everything by 2 to get rid of that 2. You get x squared equals 16. We already did a question that looked just like this. We already know what the answer is going to be. X equals positive and negative 4. Any questions about that? Just to make sure we're clear about fractions, the dreaded and awful, horrible, disgusting fraction. 2/3 a squared equals 6. How do I get rid of that 2/3? Hint, hint, you just learned it or refreshed it a moment ago. That seems 6 people. All right, Kadia. Very good. Multiply both sides by 3/2. That cancels out. You get a squared equals what, Valerie? You get a squared equals 9. Outstanding. You should already know what the solutions are. But if you don't, what number times itself equals 9? What are the two solutions? Chris? Positive or negative 3. Very good. Any comments, questions, concerns? Any comments, questions, concerns? All right, let's see how you do on your own. Checkpoint number 1. Solve this and round to the nearest hundredth if necessary. Two minutes. What'd you get? Good, we got some confident people, some people hiding desperately. We'll start with Kayla, Daniela, then Danielle, and then Sebastian. Okay, sounds very depressing. Go ahead, Danielle. I think that's the same thing she said. What did you say, Danielle? That's definitely what she said. What did you say? Plus or minus 9.64. That is correct. Give me a thumbs up if you got it correct. Put your thumbs down. Does anyone have any questions on how this was done? All right, so we're going to up the level of complexity. Let me back up for a second. We started out with kind of mid-range questions. I showed you some very low-level questions. Now we're going to up the complexity a little bit. This is also going to help prepare us for the next lesson. So now, we have a more complex-looking scenario. Instead of 5x squared equals 30, instead of simply being an x, we have an x plus 1. So that's the difference here. The good news is we take almost the same exact approach. We're just going to have a different result at the end. So what would we do here in this version of my question? What would we do here? Alexandra? Good. So that's actually what we're going to do. Divide both sides by 5. So we're going to divide by 5 here and here. This is going to disappear for us, which is what we wanted. We're going to be left with this. X plus 1 squared equals 6. Does anyone know what we're going to do now? Nathaniel? I'm rooting for you.
X squared plus 1 is 6.
No, you can't do that. You learned
It's the square of a binomial.
it's the square of a binomial. Excellent job. So we could multiply it out, because you guys actually know how to do this really well. It turns into a perfect square trinomial. But we're learning a different approach today. So anyone know what we're going to do? Okay.
Square x
I think you're saying the right thing, but you're saying the wrong word. Dalton?
square everything.
Well, that's what she said. Squaring everything, you're saying you want me to do this? You want me to square that?
No.
Yes.
To square that?
No. Square.
Okay, so
Square. 1 squared.
so what is it that they're really trying to say? Because I think Michaela and Dalton are trying to say the same thing, but they're saying it wrong. What is it that they're trying to say, Valerie? Well, we already know that it's a square of a binomial, but we're trying to use something from today. Nathaniel, you've rethought it?
Yes. Simplify it as x squared plus 2x plus 1.
We could do that. You're right. That's what you actually learned to do in chapter 9. We actually learned to multiply it out. But we're taking a different approach, so maybe you don't realize what you could do. We can square root both sides right now. How do we get rid of this? We do that. But once, to get rid of something squared, we square root it. But you have to do it to both sides. So this square root symbol will get rid of the squared, which means we will be left with x plus 1 equals plus or minus and whatever the square root of 6 is. What? We already did that one. What was this? 2.45 approximately. But now, 2.45. But now we're not done. Now we have an extra step, a couple of extra steps. There's two ways to think of this. This is what it really means. This really means we have two equations. We really have x plus 1 equals 2.45, and we have x plus 1 equals negative 2.45. We could do, guys, stick with me because some of you are going to get lost, and it's really not that hard, but you have to pay attention. That's what I wrote in green is what this really means. So don't write this down yet, but here's what I could do. Subtract 1 from both sides, subtract 1 from both sides, solve both of them. But I don't have to do that because I can just do this. Subtract 1 from both sides here, and I just have to know how to write it. This cancels out, and I'm left with x equals negative 1 plus or minus 2.45, and now I just have to do two addition problems. Now I have to do negative 1 plus 2.45, and then I need to do negative 1 minus 2.45. Use your calculator if you need to. It's not that big a deal. X will equal, I should see you either mentally calculating or writing things down. Chris, you already got it?
Yeah.
Go ahead.
X equals 1.45.
That's right. So you get two solutions. X equals 1.45 and x equals negative 3.45, which is what I would have gotten had I solved these two over here. 2.45 minus 1 is 1.45. Negative 2.45 minus 1 is negative 3.45. So my point was here that this is what this means. You don't have to write it like this. I'm just trying to show you what it means so that you can get it straight in your mind. And I would use this approach if you can understand it. Either way, you're going to get the same answers. This will get you the same answers as that. Okay? Any comments or questions? So that's the first time you saw a question like that. Let's keep working and make sure we understand how to do it. The idea is we want to isolate whatever is being squared, because we now know that we can square root a square and get what's inside the square. So if we can just isolate that, then we're golden, we're good. So do what we've done before, get rid of the 3, and we're now left with this, the square. Once we have the square, we can square root it. Square root this, and square root this. The square root symbol gets rid of the square, and we're left with m minus 4 equals. And the square root of 4 is plus or minus 2. It's a perfect square. So that's nothing different than what we already did. But now we just have this final step here. Add 4 to both sides to get rid of that. And we are left with m equals 4 plus or minus 2. And so now you can do mental math. 4 plus 2 is 6. 4 minus 2 is 2. And so you get 2 solutions. Does anyone have any questions on how we did that? All right, let's see how you do on your own. Checkpoint number 2. Solve this. You got 2 minutes. So a few people still finishing up. Take 30 seconds. All right, it seems like most people are done. What did you get? Seems to be some active discussion about who's right and who's wrong. Start with Chris, Kadir, Dalton, and Michaela. Chris, what'd you get? Okay. Okay. Let's see if that happens again.
I got 1.83 and 5.
Okay.
5.83.
So you guys agreed. You got one of them in agreement, one of them disagreed. Michaela?
X equals 5.83 and 0.17.
Okay, now I've got a divided classroom because you agree with him and they agree. Stephanie, Valerie, Edgar.
5.83 and 0.14.
So now we're leaning more towards here, Valerie. Now we got 4 people on board here, Edgar. We now seem to have overwhelming support for those 2 answers. Those are correct. And I honestly think it's an issue of the fact that you guys just subtracted wrong or weren't paying attention. So, it seems clear to me that was 7, let's see, 1, 2, 3, 4, 5, 6, 7. 7 people had at least one of the answers correct. And the other answer they got wrong, but I think they had done it correctly. When you do everything, you end up with x equals 3 plus or minus 2.83. Is that what you got?
Yeah.
So 3 plus 2.83 is 5.83. 3 minus 2.83 is 0.17. I think maybe some of my students just went a little too quickly with the subtraction, but maybe I'm wrong. Anyone still not sure where they went wrong? Okay, so now we're going to take this and take a couple minutes to apply it to the real world. I'm going to put a real world scenario up. You do not have to copy it. You need to write the name of the example and you need to read it carefully. Here we go. Similar, yeah. Anyone know what CSI stands for? It's the name of a TV show. I don't know for your time. Davis? That's right. Crime scene investigation. And this is the kind of thing that a crime scene investigator would use. Now, at this point in our world, they probably have a tablet with computer programs and models on it already where they can just take some measurements, plug it in. But someone had to actually write the program with this formula in it to make it work. So this formula is used to figure out either the speed or like the drag factor. Can figure out a number of different things from a scenario. So now you actually have to picture the scenario. Car is driving along, slams on the brakes, skids 75 feet, then stops. That's the scenario we're talking about. The question is, based on this formula, how fast was the car going? Again, this is the kind of thing that an investigator needs to know because they're trying to assign blame for an accident. Okay? If the car was going faster than the speed limit based on their calculations, they know who's to blame. Okay? So, we're going to use the formula D equals S squared over 30F. And we have the information that the car skids for 75 feet, and the road surface has a drag factor of 0.9. I cannot explain, nor am I going to go into the idea of drag factor. That's something you'll study in a science class. I actually cannot explain it. I understand the basics of it, that the road actually applies a force against the tire, but beyond that, I can't really explain it. For the purposes of this question, we need to plug in these pieces of information into the equation. D is the skid distance. So the skid distance is 75 feet, plug in a 75, equals. S is the speed, and that's what we're trying to find. S squared over 30 times the drag factor, which is 0.9. Now we only have one variable. Now we can actually solve the equation and figure out what the speed was. What can we simplify first? Or what can we do first? Kayla? Very good. You should always try to simplify anything that can be simplified. So what do we get when we simplify 30 times 0.9? Valerie? Very good. So here's where we're at. 75 equals s squared over 27. How do we get these s squared by itself? Edgar? Sure? Okay, Nathaniel? Okay.
27 over s squared.
Well, if I multiply by 27 over s squared, then the whole thing is going to disappear. I don't want the s squared to disappear.
Times by 27.
Yeah, so we're just going to multiply times 27 on both sides. This will cancel this, and now here's where we're at. We've got s squared equals what? S squared equals what? What did it come out to? Comes out to 2,025. Anyone know anything about the number 2,025? Danielle? Yeah, it's a perfect square. Anyone know what the square root of it is? Danielle? It's 45. So, magic of calculators. Square root both sides. Square root this, and we get s equals plus or minus 45. So someone tell us, how fast was the car going? Edgar? 45 miles per hour. It couldn't have been going negative 45 miles per hour because this is not taking place in a science fiction movie. So, any questions on how this was done? Good, we're doing an outstanding job so far. Now you have the opportunity to work on your own with classmates near you. Draw a line across your paper. Your classwork is page 107. You're going to do numbers 25, 23, 21, 18, 16, 14, and 9. Got 7 questions. Got a little less than 15 minutes. Say about 13 minutes. I will be circulating to assist. Talk to your classmates about what you're doing. Compare your answers with your classmates. Decide if you need help. Work hard. Yes, it does. Oh. Okay.
Yes, you didn't finish.
I multiplied it out.
So here you go.
It's actually positive.
All right. Colored pens up, and let's see how we are doing. I was very impressed with the effort and the discussion, and particularly impressed with students trying to convince others, their peers, that they were right or why they took the approach that they took. I was very impressed with that. So keep up that outstanding work. Let's see how we did as far as the answers. Number 25 comes out to approximately 3 inches. As long as you wrote anything close to 3, I will accept it. All right, number 23 comes out to approximately 6.16 inches. 21 comes out to 2 solutions, 1.55 and 6.45. Number 18 has no solution. Number 16 comes out to plus or minus 4.12. And the last two were super ridiculously easy. Comes out to 0. And number 9 comes out to plus or minus 1. So, let's take a look at 25 for a moment. So here's number 25. Give me a thumbs up if you got it correct. Good, put your thumbs down. So now I want you to watch and see if you got part of the way, most of the way. See if any of this is true for you. First of all, you're given a formula and you have information to plug in. We end up with this. Excuse me. What you should have realized is that you can multiply the 3.14 times the 6, and so you end up with this. And for us, that's a simple thing to do. Divide both sides by 18.84. This disappears, and we get r squared equals, who has what it comes out to? Kayla, you do. What does it come out to? 2.23. I just couldn't hear you. Thank you. 2.23. Now you take the square root of both sides. Square root, and you end up with r is approximately equal to 1.49. So why is that not the answer? You did all that work. Sebastian? Yeah, you are asked for the diameter. What should the diameter be? So what do I have to do with 1.49 to get the diameter? Kayla? Multiply it times 2, and you get very close to 3. Okay? Yes, technically you get plus or minus 1.49, but there's no such thing as negative distance. Okay? Give me a thumbs up if you got at least part of the way for that question. At least part of the way. Good. So there's a lot of good news with that question. Good. Put your thumbs down. Again, I'm very, very impressed with the effort today. So, draw a line across your paper. Your homework is page 677, numbers 4 through 48 even, 56, 58, and 60. Read page 685 to 687, and you are going to have a quiz tomorrow. That will be 10.1 to 10.3. So of course,